Let's try to render the asset we imported earlier by right-clicking on the node and choosing Preview Render. You can see that our render has errored. If you switch over to the Render Log tab, you will see that it is trying to find a camera that does not exist in our scene. Let's create a camera. I'm typing CC to filter down to the Camera Create node. If you inspect this node's parameters, you can see that it creates it at the default location that our error render was looking for. Now we need to merge this camera into the hierarchy with our assets. Select both nodes and press the M key on your keyboard. Set the view flag on the merge node, and you can now see this camera location has been added to the scene graph. Go to the viewer and click on the camera shutter icon. You should be able to see the camera in this widget. If you do not see it, ensure that the view flag is set on the merge node. Select the camera from this widget to look through it. Let's position the camera so that we can see some of our assets. Use the Ctrl+P hotkey to launch a preview render. The Ctrl+P hotkey launches a render from any node that you set the view flag on. Even though the render does an error, we have a black image in the monitor tab. This is because we don't have any lights in our scene. Press Tab and type Gaffer 3. Press Enter to select. Gaffer 3 is what Katana calls a super tool. We will learn about the Gaffer 3 node in more detail in the next lesson. But for now, you can think of it as a tool within Katana that makes creating and manipulating lights a lot easier. Set the edit flag on the Gaffer 3 node. Next, right-click on the Gaffer interface. From the pop-up menu, go to Add PRMan Light and choose Pixar Dome Light. Select the dome light and press the Enter key to rename it. I'm going to call this Dome Light. Let's right-click on the Gaffer 3 node and choose Preview Render. As you can see, we now have some simple lighting in our scene. While we can continue to work on the lighting using the Gaffer 3 node, I think it's important to learn about some of the building blocks of what makes tools like Gaffer 3 work. So I'm going to delete the Gaffer 3 node and create the lights manually. And while you should always try to use tools like the Gaffer 3 that is designed to make life easier for us, understanding how it all works will enable you to design your own super tools. Press Tab and type in LC and choose the Light Create node. Set the edit flag on the Light Create node. I'm going to call my light Sky Dome. Like before, we need to merge the light into our main branch. You can now see that the light location has been added to our hierarchy. Can you guess what will happen now if you try to render it? Once again, the render is black. This is because RenderMan only knows that a location of the type light exists, but it has no idea what kind of light it is. In order to do this, we need to create a light material. Press Tab and create a material node. From the Add Shader button, choose the light shader grouped under PRMan. I'll call this mat_HDRI. Next, we need to assign the light shader. Click on the drop-down menu next to the PRMan light shader and choose Pixar Dome Light. Expand the parameters of the shader by clicking on the gray arrow. Click on the arrow next to the color map and choose an HDRI image. If you set your view flag on this node, you can see that a new material location has been added to the scene graph. However, this light does not know about this new material. For this, we need to assign this new light material to our light location. Create a material assign node, and I'll call this MA_HDRI. In the material assign path, shift middle click and drag the material node into it. And similarly, shift middle click and drag the light create node into the add statements on the material assign node. When you do it this way, the locations are expression linked. So if you change the name of the light in the light create node and change its name from Sky Dome to HDRI, it is automatically updated. If we render this now, you can see that we're finally able to see an image, and we can also see our HDRI in the background. However, the geometry has no shaders assigned to them, so it is picking up a default shader. Let's assign a gray shader to all of the geometry. Create a material node and call it Gray Shader. Under Add Shader, choose BHDF and choose Pixar Surface from the drop-down menu. Now let's assign the shader to the geometry by creating a material assign node. I'll call it MA_Gray Shader. I'll choose the Hidden People ABC location from the scene graph and middle click and drag it to the add statements on the material assign node. Adding your material here makes every location under it inherited as well. If you render it now, you can see that we now have the gray shader applied to everything. I don't really like the fact that our renders are square, so I will change the resolution to Full HD by creating a render settings node, and next to resolution, choose HD. If you render now, you can see that the resolution has changed, but the image appears stretched. Go back to our render settings node, and next to the adjust screen window parameter, choose adjust width to match resolution. If you render it now, you can see that the image is no longer stretched. I need to be able to iterate faster while I work, and this render took a while, so before we proceed to the next lesson, we will add some RenderMan specific nodes that will allow us to control the quality of the render. First, I will create a PRMan integrator settings node and choose the Pixar Path Tracer integrator. RenderMan comes with several integrators you can choose from. An integrator is the algorithm used to compute lighting, and the choice generally depends on the scene you want to light. For a simple exterior setup like ours, with relatively simple lighting, the Pixar Path Tracer is usually the best choice. RenderMan also comes with integrators like VCM, which is more suitable for complex lighting setups with several hidden lights, or when you want caustics to be rendered more accurately. The PRMan integrator settings node contains parameters specific to the chosen integrator. The node can also be used to either initialize a new integrator or edit an already existing integrator in your scene. We will look at this in more detail in an upcoming lesson. Next, I'll create a PRMan global statements node. The PRMan global statement nodes contain parameters to control the global rendering parameters used for rendering, such as sampling, pixel filtering algorithms, and many others. We will go through some of these in the lighting and rendering lessons. Set the pixel variance to 0.1, and the min samples to 1, and the max samples to 16. And finally, we will enable the incremental option. And you can now see that we are able to see our renders much faster. While it is not the best quality, it is good enough for us to be able to judge our work. In the next lesson, we will use the Gaffer 3 nodes to intuitively set up lights.